Hello everyone, welcome back to Praveen online classes. Now we have already seen the derivation of mirror formula from this chapter, that is curved surfaces, reflections, and now we will see the sign convention of mirror formula that we are having, that how we are going to take image distance, how we are going to take object distance, focal length, everything we will get to know here. And both, I will give you the sign convention for both, that is concave mirror and convex mirror. I have notes for you, and you will get these notes in the form of PDF, in your BioLink, in the BioLink and the description below I have it. Now, moving ahead, let me draw this diagram that is being over here, written over here, that is new Cartesian sign convention. That means that we should have a diagram of anything, let's say concave and convex, and from there I'll teach you how will I have to take the sign convention of each, let's say focal length, image distance, object distance, everything. And with this next thing will be coming up is magnification, and after that we will be solving sums on mirror formula, sums on the mirror formula. From exam point of view, I will tell you what all are the things important and what is the keywords that you need to look into from the question, so that the things you need to write it properly, everything should be written in properly, so that everything will get into your, and you will be able to fetch full marks in yours board. Now let me draw the ray diagram for the same, so that I will be able to explain. Let me draw. Now let's say this is a concave mirror. This is a concave mirror I have, and I am drawing principal axis. This is an arrow, and this I am keeping it over here. Now let this be a center of curvature, this be a focus, and this is a pole, Now below this I am also drawing one integer line, so that you will understand which one should you take positive and which one should you take negative. Now in integer, you know that over here whatsoever line we have it, these are positive. I am talking about on number line. Now whatever things I have it over here, on this number line will be negative. Now let's say anything which is coming like this is positive. Anything which is coming like this is positive, which is because it is going above the axis, above the x-axis. That you need to take it as a positive. Why am I telling you this is because you need to take height of an image or height of an object. You need to take it. Now if I am taking anything below like this will be negative, and anything which is standing top to the x-axis is positive. Now let's say I have an object beyond C. Object beyond C means the height of an object. Let's say this is a 2 centimeter. So height of an object is represented by small h and letter small o. You can write it like this: small o, h, height of an object. This is the height of an object. Now on top of it there is an incident ray goes. Incident ray goes, and after striking the mirror, you know that it will pass through focus. It is passing through focus. Now again, the other rule that we have, the second rule, is whenever incident ray passing through focus, after striking the mirror, it will get parallel to principal axis. It will get parallel to principal axis. It will get parallel to principal axis. This arrow is like this, and it will get parallel to principal axis. Your image formation is over here. Now how do we need to take sign convention of object, sign convention of image, and focal length. Now if you see, whatever, if you see, this is an origin. Where is the origin over here? My pole is the origin. Please remember guys, my pole is an origin. Now whatever we are taking to the left hand side of the origin will be negative. To the left hand side of the origin will be negative. Now whatever we are taking to the right hand side of the origin will be positive. Same thing which has been shown below. Which have been shown. Now this point that I showed you, the O is nothing but origin. O is nothing but origin. Now I told you, whatever we are taking from left hand side of the origin, left hand side of the origin will be taken as negative. Negative. How do you need to take negative? Because whatever is falling over here, whatever is falling over here, and I told you all that if you are taking above x-axis, that is positive. Hence height of the object is positive. Now height of the object, object distance. Object distance is nothing but from this distance to this pole. Pole is indicating it over here. This is represented by letter U. This is represented by letter U. Now I am talking about concave. So you know that for concave mirror, everything is in negative. Everything is in negative. We are taking the distance from pole to the object distance here. To the object distance here to the pole. That's why I am indicating by letter U, which is taken as negative. Same thing applies to your image distance. Image distance is nothing but from here, this distance and this distance. We need to take this in equivalent to pole. So that is represented by letter V, which is also in left hand side. That is also negative. Now the catch point. If you look at for the focal length, you know that the focal length is nothing but the distance from pole to focus. The distance from pole to focus. I am talking about this distance. This distance is focal length, which is also in the left hand side. So in concave mirror, focal length is also negative. Now height of an object is positive. Height of the object is positive. But you will see image is inverted. Hence height of an image that is represented by H and small I, that is taken as negative because it is inverted, as I have shown you over here. Now I hope if you want, you people can make this diagram so that everything will be visible and clear to you, and you can draw it by your own so that you will understand properly. Now only difference in sign convention of concave and convex mirror is, for concave everything is negative. No matter you are taking object distance, image distance, focal length will be negative, except in one case, that is the sixth case, wherein your image formation will be here. And the object will be placed between focus and pole. In that case we get a virtual image. So you know that virtual image is always upright and erect. Now coming back to convex mirror. In convex mirror, object distance and image distance will be negative, but your focal length will be positive. Because for this focal length lies on the right hand side. For convex mirror, focal length lies on the right hand side. That's why it is positive. Please make a note of the same, so that while solving you will be able to know this. Now let me continue with the same. Now as I told you, all the distance are measured from the pole. So the distance in the direction of incident ray, the way I have drawn the direction of the incident ray, is taken as positive. Okay, the distance when it is taken as positive, when it is falling on the right hand side, but it is falling on the left hand side. Whenever it will fall on the left hand side, you need to take the distance should be negative. Okay, for concave mirror and convex mirror both. Let's say the distance from opposite direction of the incident ray will be taken as negative. Same thing applies. The height of the principal axis is positive, which has been shown, and also height below the principal axis, which I have already drawn and shown, will be taken as negative. Now, one more thing. Sign convention table that I have for both. Focal length is negative in concave, convex it is positive. Now, radius of curvature same. Radius of curvature same. Over here it will be negative, and over here it will be positive. Now, a quick question to you guys. Kindly comment in the comment box what is the relationship between focal length and radius of curvature. Now, the next thing that we have over here, the object distance is negative. And over here this is also negative. For concave and convex both is negative. Image distance. Now you should know that the catch point over here is whenever image formation is real and inverted, that its sign convention will be negative. Its sign convention will always be negative. Please keep this in your mind. This is very important. Whenever image is virtual and upright, it is taken as positive. Whenever image is real and inverted, it is taken as negative. Same thing has been shown over here. Image real, negative, and not form, because it will form at infinity. This is you can see the heading over here. One second. Okay. Yeah. You can see this is for convex mirror, and that is for concave mirror. Now the next part that we have is called magnification. Can anyone define magnification for me, and why do we need to magnify anything? What do you mean by magnification? At least anyone? You might have heard or you might have seen that people who are reading anything, if they are not able to read, they use magnifying glass. Magnifying glass is something which contains of lenses, but that magnification and this magnification is a bit different. Now, this magnification is nothing but it is a ratio of one second. It is a ratio of height of the image. The dot sign that we have over here is nothing but m is equal to height of the image by height of the object. Please make sure that this is a ratio. Now, please can anyone tell me, if you are taking ratio of any two same quantity, will it have any unit or not? Likewise, we have magnification. Does magnification have any unit or not? Kindly comment in the comment box. Now, this magnification is defined as the ratio of height of the image by height of an object. Height of an object. Now, there is one more formula for the same. Is negative height of the image distance of the image by distance of object. This is very important for you guys to solve problems. Now you know that this is nothing but image distance, and this is nothing but object distance. So if height of the image is given, height of the object is not given, and you have these things given, you will be able to find this. Or if magnification is given, alternatively you will be able to relate it, same like maths, you will be able to relate it and find all the things whatsoever is not given over here. Whatsoever is not given over here, over here. Now, the best thing that you should know and you should interpret is very important. Interpretation of magnification. Interpretation of magnification. Whenever magnification is greater than 1, your image will be a large image. And whenever it is equal to 1 is equal to 1, then it is same size of the image. Now I request everyone, whomsoever is watching, can you please comment in the comment box that in which ray diagram of concave mirror I had image size of the image and size of the object is same. Can anyone comment, please? Can anyone comment in the comment box in which case of ray diagram of concave mirror the object size and image size is same? Image size is same. Now moving on, we have if the magnification is between greater than 0 and less than 1, then it is called diminished. The word diminished I have already explained in the first video of mine. Kindly go and check what does it mean. And now I already told you, whenever there is a formation of real image, it will be, magnification will be always less than 0. Magnification will be always less than 0. Now, the important thing that you need to know is important ray diagram notes, very important. For concave, parallel ray will pass through focus after reflection. This is the rule that is there. And for concave ray, parallel ray will appear to diverge from the focus, because this one is called converging mirror and this one, the convex, is called diverging mirror. Now, okay, the last thing that we have, if the object is at infinity, forms at focus. Everyone knows this because you people have already given. Now let me give you one example. Given that if object distance is given as -20 and image distance is given as -40 centimeter, then your this. Can anyone tell me after calculation? How much will be my magnification? How much will be my magnification? As I told you that the next magnification can also be given as height of the image by height of the object, and also this is equal to negative distance of the image by object distance. Over here, these are the two things given. But height of the image and height of the object is not given. Hence, we will have to use this formula. Which is already given over here. And if you will calculate it, you will get -2. Now, why am I getting -2? Because as you know that in concave mirror, image distance is taken as negative. So what will I do is, this is given. Let me write it again. One moment. Yes. Now I was writing that in concave mirror, image distance that I have is negative. How much given? -20. Object distance, how much it is given? -40 centimeter. This is also in centimeter. Now my formula for magnification is negative image distance by u. So I will substitute this. Negative sign will remain same, and instead of this v, I will substitute -20. Instead of this v, I will substitute -20 by -40. This negative will go, and this is 1 by, this is 21s are 22s are, and you are getting m is equal to -1 by 2. -1 by 2. 1 second, let me check once again. Oh, sorry. I have taken the distance I have taken the wrong values. I have taken the wrong values. I want you guys to correct me. I want you guys to correct me, and same thing has been given over here. If you solve it, you will get as negative. Now, can anyone tell me, if magnification is negative, what is the nature of the image that we have got? Whether it is real or inverted. Please comment in the comment box. Please comment in the comment box. Now, moving ahead. This is a quick revision for all. Quick revision for all. You should know that in concave mirror, focal length is negative. In convex mirror, focal length is positive. I have already told you. And in real image, magnification is negative. So I hope I gave you the answer for this. Now I have virtual image, magnification is always positive. The biggest thing that you should know is mirror formula is applicable for both concave and convex mirror. Now this is the mind map if you want to remember it. Mirror sign convention, mirror formula, magnification and image characteristics, numerical problems will be having it. Now, numerical problems. Now, if I have a time, I will give you 5 problems or at max 3 problems to you guys to solve it and come in a next video. And I will solve it by my own. Now, we'll meet in the next video of mine. Thank you so much for watching, and please keep subscribing, keep sharing, so that I will be able to reach to all of them or the people who are interested to study physics online. Thank you so much.